So welcome back children, and today let us learn about the characteristics of group. In my previous video I taught you about the characteristics of periods, and now it's the turn of groups, and we'll see how the different characteristics they change in a group when you go from top to bottom in the long form of periodic table. As you know that there are 18 groups present in the long form of periodic table, and if you talk about the valence electrons, all the elements in a particular group will have same number of valence electrons. This is what you should know. So in a group, for example, if you take this group 1 elements, all the elements will have the electronic configuration showing the number of valence electrons to be 1 only. This is where the electron starts filling up, it starts to or enters a new shell. You can see first shell and a second shell. Can you see this? So all the elements, it is grouped or classified in such a way that all the elements in a particular group of the periodic table will have same number of valence electrons. So here is an example of group 2 elements. You can see that the valence electrons are 2. And this is the 13th group elements. Now you tell me the groups from 3rd to 12th, they are called as the transition metals. This you will be learning in your higher class. Apart from them, the 13th group elements will have valence electrons of 3, and the 17th group elements. When I talk about 17th group, you have to deduct 10 from it, and that gives you the number of electrons which are present in the outermost shell there. So if it is 13th, 13 minus 10, 3 electrons. 14th, 14 minus 10, 4 electrons. Valence electrons will be present in the outermost shell. In the similar manner, this is the 17th group group of elements, fluorine, chlorine, bromine, iodine, and so on. So here you will have, you see the electronic configurations in a particular group. The electronic configurations are similar. Can you see this? Outermost valence electrons are 7 only. Then if you talk about the 18th group or the 0 group elements, there the valence electrons will be 8 electrons will be there in the 18th group elements. 18 minus 10 is nothing but 8 electrons. Now when you know the valence electrons, now we'll be getting a very fair idea of the valency also, right? So here it is 1 electron is present, it can easily lose electron, and so its valency becomes 1. Second group elements, the valency is 2. 13th group elements, the valency is 3. 14th group elements, the valency is 4. But 15th group elements, the valency becomes again 3. We saw that in the characteristics of periods. First, as you go from left to right, the valency first increases up to 4, and then it decreases until it becomes 0 in the 0th group of elements. So this is the 17th group element. How many electrons it requires to get the octet configuration? It requires only 1 electron, isn't it? So that it becomes similar to that of the stable nearest inert gas configuration, which is nothing but neon, right? So the valency of this 17th group elements becomes 1. All the elements will have same valency in a group in the long form of periodic table. Coming to the atomic radii. Now we are talking about the atomic radii. I just spoke about it. What is an atomic radius, children? So atomic radius is nothing but the distance between or from the nucleus to the outermost shell. As you know that in a group, you can see here that these are all in terms of picometers. They are expressed in terms of picometers, atomic radii, and you can see that there is a gradual increase as you go from top to bottom. The atomic size increases. So it's very good, easy or logical explanation is that a new shell actually adds up. So that's the reason why every time as you go from top to bottom in a group, the number of shells increase, and so the number of size also. So the size also increases corresponding to the number of shells that a particular atom has, element has. So you can see that the atomic radii, it increases. The atomic size or the atomic radii, it increases when you go from top to bottom in a particular group. So here also gradually in every group, gradually from top to bottom, you see that the atomic radius increases. Coming to the metallic nature, this is a bit tricky. Please do try and understand, children. Metallic nature, it increases. Metallic nature increases when you go from top to bottom. Okay, you understand this? If you see like that, if you just apply that here, francium actually is the most metallic element and lithium is the least metallic element. I'll tell you the reason for this. You can see that here there are only two shells, K and L. When you go down, there will be more number of shells in francium, right? So what happens is, when compared to lithium, francium will have no hold on the outermost electron. So what is valency? It corresponds to the outermost electron. Only outermost electrons can be lost or gained, right? So when it comes to francium, corresponding or owing to the more number of shells as well as higher atomic radii, larger atomic radii, so it becomes difficult for the nucleus to hold the outermost electron, and so it easily loses it. So when a particular element easily loses electron, it becomes easily electropositive, it becomes most reactive, right? So when you see from top to bottom, as the size is gradually increasing, gradually the metallic nature also increases, because the nucleus is no longer able to hold that one electron, and so it easily gives away. So the metallic nature of the group 1 elements, it slowly, when you go from top to bottom, it increases, making francium the most reactive metal, or what you call, it has the most electropositive nature. Now talking about the non-metal group, can you see here? So the 17th group element, if you talk about the halogen groups, if you talk about, the non-metallic nature decreases. The non-metallic nature, it decreases from top to bottom. So you can see that the fluorine is the most reactive, or what you call, fluorine is the most electronegative, or I can say fluorine is the most non-metal element, non-metallic element. Why now you tell me? Here you have to gain electrons. This is opposite to that of the, when you compare with that of the group 1 element, it is quite opposite. Here you should not lose electrons. You should gain electrons, and after gaining, the nucleus has to hold those shared, or what you call, gained electrons also. So that will happen, that will be more feasible if the atomic size is smaller. If the atomic size is smaller, nucleus can have a good grip over the outermost electrons, and that's the reason why, you know, the fluorine becomes the most non-metallic element, or what you call, most reactive element in that group. When compared to the other, when you go from top to bottom, the non-metallic nature decreases, as well as so is the chemical reactivity also. The chemical reactivity also decreases here. Here the chemical reactivity increases, here the chemical reactivity decreases, children. Hope you know the reason now. Did you understand? It's mainly owing to the larger, or what you call, the atomic radii. If the atomic radii is smaller, you know, it cannot easily give away the electron. If the atomic size is bigger, it can easily give away, which makes francium the most electropositive element. And fluorine now gaining electron and holding it. Fluorine, it is possible only when the atomic size is smaller. Fluorine has the smallest or the least atomic size, smallest atomic size when compared to the other elements. That's the reason why fluorine becomes the most reactive or most electronegative element. So owing to that electronegativity, it becomes the most reactive element too. For the first time, it would sound little confusing, children. Please go through my video again and again and refer the textbook. You will know, I think in your textbook, all these reasons are not properly given. Please do listen to my video and understand the concepts well. So with this, I think we complete our syllabus. I'll be giving few questions for you to practice, and please do note down, please do follow the posts. I'll be posting a few questions for you to frame the answers to. Okay, thank you.